Hello everyone, so this is Sonu and today we are going to discuss the problem from the LeetCode, and the statement is given as we have to calculate the sum of the subsequences with. So let us see the statement of the problem. So yeah, I hope the screen is visible. So the problem statement is given as, this is the hard level problem from the LeetCode. So it is given that the width of the subsequences is the difference between the maximum and minimum elements in a subsequences. For example, let's say we have the arrays given as 2 1 3. So what will be the sum of the all the difference of the min and max of the each subsequences that we can generate from this particular array? So let's say for this 2 and 3, total subsequences are this one. 1 2 means for 1 1 elements, and then 2 2 elements, and then combination of the 3 elements. So these are the three, and this 3 6, and one is 7. So for each one, for a single element, what will be the maximum and minimum? We know for a single and subsequences for which the element is 1, means the number of elements is 1, then what will be the maximum and minimum? Both will be same. So one will be the max and one will be also the mean. So difference will be what? 0. That's why it is given 0. Similarly for 2, the max and min will be again 2, difference will be 0. Again for 3, the max and min will be 3, that's why the difference is given 0. For this part, the max and min is 2 and 1, so difference will be 1. Similarly 2 3, difference will be 1. 1 3, the difference will be 2, and for this one the min is 1 and max is 3, so difference is again 2. So if we count sum all these differences, so what will be the answer? 1 2 and this one 2 2, so total will be 6. So the width of the subsequences is 6. So these are the so this is the one example for this problem. Similarly for a single element, the difference will be 0 because the 2 is the max and 2 is the mean. So again here the difference will be 0. So now looking at the constraint, it is given as the arrays will be of 10 raised to power 5, and here the size of each element is ranging from the 1 to 10 raised to power 5. So from this statement we are quite sure that the exponential solution is not going to help at all, because for solving this one the very basic approach we have, like the method means the way we used to generate the subsequences. For example, let's say we have one example here. Let's say the element is given as 1 2 and 3. So the subsequences we will generate, one is the empty, one is 1, one is 2, one is 3, and one is the combination of 1 2 1 2, and another is 1 3, and our next is 2 3, and next is 1 2 3. So these are the subsequences. So for this one, for single element, we know already the max and min difference will be zeros, and for this one we can calculate by generating. So the approach to generate the subsequences, we know for 1 2 3 how we can generate, like we'll include the 1 into our answer and we'll call recursion on 2 3. Similarly for next time we will not include 1 in our answer and we'll call on 2 3. So answer will be blank and recursion will go to 2 3. Again here the same approach is there, and once we will hit the base case, then we'll have the subsequences. So these are the basic approaches, but by moving in this idea, how we can calculate our answer? So this is the main point. So once we are including anything into our output, means our subsequences, so we can keep the track of these two variables. One is for mean and one is for max. So whenever we are including any element into our the subsequences, we will just update the max and mean with the current element that we are including into our answer. For example, let's say just run this approach with one example. Let's say 1 2 3 is there. So what we will do, we will keep 3 variables. One is max, and one is mean, and one is our answer that is the sum, and we will initialize the sum as 0, and max mean will be plus infinity and max will be minus infinity. So just when the recursion will call, so one we are including and we will call recursion on 2 3. So for the first one, whenever we are including any element into our answer, we'll just update the max and mean. So max will be of minus infinity and 1. So it will be like, see how the max will be updated. Max will be of max of this one, the element that we are including, and the older values. That is the already max. Just don't confuse with the name. This max is the older one, and this max is the function, and this is the updated value of the max. So max will be updated to 1, and similarly mean will be updated to 1. So first element we have included into our answer. So similarly, again the recursion will call on, it will include 2 into our output, and it will call recursion on 3 again. The max will be 2, but mean will be not updated because we are including 2 into our answer. Of mean of 1 and 2 will be still 1, so we don't have to update the mean. Again it will call on the 1 2 and 3. It will call on the blank one, and once it will reach the base cases, means it is the condition of the base case. So at this position we just have to print not print, just have to take the difference between max and mean. So we are including 3 into our subsequences. Accordingly we have to update the max and mean. The max will be 3, but mean will be still 2. So here at this position we are at the base cases, so just we need to return the difference between this max and mean. So this will return the 3 minus 1 is 2. So this will return 2, and here again it will call on 1 2, but here it has a choice that 3 is included, so at this time it will not include, so it will call on blank. So for this part again the max will be what, 2, but mean will be 1. So this will return 1. Again it will add 2 and 3, and this part will return to 3. Again this part will call on what, 2 is included, but this time we will not include 2. So the earlier subsequences was only 1, and we will call on 3, and again it will call on 1, and it will include 3, 1 3, and the next time it will not include 3, so 1, and it will call on the blank. So here this part 1 and 3 will be there. So from here it will return 2, but this will return the single element is there. For single element, what the max and min will be same, so this will return 0, and this will be added 2 and 0, so this will return 2, and this part we will return 3 plus 2, 5 to 1 to 3, and again it will call, and so on. So we know the brute force approach we can solve easily by the once anyone can who is knowing the process of generating these subsequences, he can solve easily this problem. But the time complexity will be exponential. But looking on the constraint on the problem given on the LeetCode, it is not acceptable. Means it will not be able to submit in the exponential time complexity. So we need to think some smarter way. So let's try with some other approaches that will help us here. So we will do a little bit of mathematics here. So just consider here, let's say you have the element as A0, A1, A2. Let's say first the array is given of size n here. Now one observation I want to show you. Now my question is if we sort this array, so sorting will affect our answer or not? The very first question, just you need to think carefully. Sorting will affect the answer or not? Just consider this one, the example 1 2 3. For 1 2 3, these are the subsequences. If we have the 1 3 2, let's say the element in the given array. What are the subsequences here? Again the empty one, again the 1, again 2 3 1 3 1 2 and 3 2, and next is 1 3 2. Here this part, the single element is matching directly for the sorted and unsorted arrays. Here, this, let's say this one is the unsorted and this one is the sorted. So for both of these parts are common, but for 1 and 3, for means considering two elements, here just the ordering will be changed. Means 1 3 here, here 1 3, 1 2, 1 2, but here 3 2, here 2 3. Just ordering is getting changed, but the max and min will not affect, because we have the collection of n elements or k elements. Then max and min will be always same whenever you are shuffling the elements in between them. It will not affect the max and min values. So here the ordering or means ordering of the elements means sorting will not affect the final answer. So here one conclusion we have, sorting will not affect the final answer. So let's say we have given n elements and we have sorted this, and after sorting we will have the subsequence, means we have the sequence like a0 n, a2, a3, so on, till n minus 1. Now consider the contribution of the ith element into the final answer. We need to think this point at that is how much the AI is contributing to the final answer. Final answer means the difference between the maximum and minimum, right? Means from this point we need to think that what are the all subsequences for which AI is the maximum element, and what are all the subsequences for which AI is the smallest element. Just keep in mind these 2 points. We need to think that how we can calculate the contribution. There is only way. We need to think that what are the all the subsequences for which AI is the lowest value, and what are the all the subsequences for which AI is the maximum values. Once we will have this information, we'll easily able to crack this problem. So just try to answer these 2 queries, like what are the subsequences for which AI is the smallest one, and for which means all the subsequences for which AI is the largest one. And once we will have this answers for these 2 queries, we'll able to answer this easily. So let us try this one. So let's say we have a0, a1, a2, a3, and so on, n minus 1 number of elements, and we are trying to find the contribution of the ith elements, means AI elements, means the ith element. So how many elements will be below? Total I elements will be there if we start from a0. So total including a0 to ai minus 1, how many total elements? I will be there, and from here ai plus 1 to, from ai plus 1 to an minus 1, how many elements will be there? This will be total n minus I minus 1 elements will be there, and here I elements will be there, and this one is the 1 element. So the question is, the subsequences is generated by a02 till ai minus 1 for these subsequences, means we can simply say, means how many subsequences is there for which AI is the largest one. So largest one, how we can conclude this one? By this way, right? And similarly, how many subsequences for which the AI is the smallest one? So here AI is the smallest one, we need to check. Means first part we will see the AI is the largest one. So let's say we have 0, 1, 2, 3, and so on. Let's say this one is the I minus 1 index and this one is the I. So for this part, this is fixed. Means at this position, AI can come only, means AI is placed only. We don't have to place any other elements. So for remaining total I places, these are the, how many places are there? These are the I places. So for and for this one, how many elements are there? We have total I elements are also there. So every element means at this position, an element will come or not. Means for let's say a naught will come or not. There are 2 choices. Again, at this position, an element will come or not. So for every element means there are two choices, whether that element will go to at this places or not. So total, how many elements are there? I elements are there. So how many total number of ways to generate these subsequences? 2 raised to power I, right? So what will be the contribution for all the subsequences for which AI is the largest one? Again, I am repeating, please keep in mind AI is the largest one. So total contribution of this subsequence means AI, in which is the largest one, will be 2 raised to power I into AI. So this is the contribution of the AI element in which AI is the largest one, right? I think you are not getting confused. You are getting what I'm trying to explain. Similarly, now consider the all the subsequence for which AI is the smallest one. So AI plus 1 and next an minus 1. So these are the elements. So again here we have this position, this one, this one till n minus 1. So this is the ith and this is the I plus 1 and so on. So here at this position again AI is fixed. No other element can come here. So only one choices is there for ith position. So remaining how many positions are there? N minus I minus 1 positions are there. So for how many total number of subsequences we can generate? It's clear by the previous explanation. 2 raised to power n minus I minus 1. I think it is clear. It is not confusing you. So what will be the contribution of this AI element for which means for all the subsequences for which the AI is the smallest one? So AI into 2 raised to power n minus I minus 1. So this is the contribution in case of lower bound, and in case of upper bound the contribution of AI is 2 raised to power I. So we have these two equations, two values. So what this is representing? This is representing the contribution of the AI element in all the subsequences for which AI is the smallest one, and this is representing the contribution of AI into all the subsequences for which AI is the largest one. And for all the subsequences, I mean we can generate from the given arrays, right? So what will be the difference between these two? Means for actual contribution we need to check the difference actually, because for max and mean, so the max and mean will be the difference will be AI and the 2 raised to power I, which is the upper bound, and because it will be the max element for all such subsequences, and for 2 raised to power n minus I minus 1. So these are the contribution of the AI into our final answer. So for getting the contribution of all the elements, what we need to do? We need to do just summation from where I equal to 0 to n minus 1. Means for all elements clearly. Again, we can simplify this statement. Here, what we can write? A0 into 2 raised to power 0 minus 2 raised to power n minus 1 plus a1 into 2 raised to power 1 minus 2 raised to power, if we'll put n equal I equal to 1, n minus 2 will be there, and so on. A n minus 1 into 2 raised to power n minus 1 minus, for I equal to n minus 1 I am writing. So if we'll put I equal to n minus 1, so it will become 2 raised to power 0. So now just do one thing, just take here the 2 raised to power 0 common. So once you will take 2 raised to power 0 common, what will be there? From this factor, we have the a naught common, means a0. And where is 2 raised to power 0 is again? 2 raised to power 0 is present here. So here what will come? A n minus 1, right? Similarly, plus, sorry, yeah, not 2 raised to power 1 we will take common. So for 2 raised to power 1, what it is? A1. Again 2 raised to power 1 here just before a n minus 2 will be there, and 2 raised to power n minus 2 and minus 2 raised to power 1 will be there, right? So here what will be the common? A n minus 2. And similarly so on for the last element, what will be there? 2 raised to power n minus 1, and here we have the a n minus 1 minus, if we are taking 2 raised to power n minus 1, so here a0 will be there, a0, right? So what we can write this part again, we can write the summation of I equal to 0 to n minus 1 and 2 raised to power I into ai minus a n minus I minus 1. That is the first element, last element, second element, second last element. Just we need to multiply this one. So I think we can solve this in one go, in one traversal. So final answer will be this one. So I think you will get the complete picture of this problem from these places. So now how we can code this? So for coding part, I'm not going to write every line. I have already coded both the solution, and I will show you just here. So let's say I have taken one example. One is the given arrays I have taken. So what I did here, I have written two methods. One is for optimized one, and one is for brute force that I have discussed in the solution. So first, let's see the brute force approaches. Brute force approach is nothing but just I am taking the arrays, and here I'm maintaining the two variable max and min, and one is for traversing, that is the kind of virtual pointer. So here, what we are doing, once the I will reach at the end of the arrays, means we are at the base case. So when we will be at the base case, then let's say the point is here, one I have discussed here. Once we will have one subsequences kind of empty where no element will be there. At this point, what will happen? Actually, we are passing from the here at the max, we are passing the mean values, that is minus infinity, the kind of means for a particular language, and this one is the plus infinity. So this will be not updated. So just I'm checking that whether my max and min is still same that we have passed earlier. So if it is same, that we don't have to do anything, we just return 0. Else it is not the case, means we are not having the subsequences kind of this one, means this is a case for like 1 or 2 3 or 1 2 1 3. So for such cases, we'll just return the difference of these two values, that is the max and minus mean. So these are the base case, and these things you need to handle carefully, otherwise you will get the wrong answer. And after that, what I'm doing, I'm not nothing but just the process for generating the subsequences. So what I'm doing, I'm in the first call, I'm including the element, and in the second call, I'm excluding the elements, means into our output. So once we will include the element into our output, then accordingly, you need to update the max and min values, right? So once I will update the max and min values, so here the max is I am passing by updating the max, and min I am passing by updating the min, and you need to go to the next element. This is the first case, and the second case is just we are passing max and min because we are not including the current element into our the subsequence part, and this is for traversing the next element. And once the recursion will give these two answers, we will just add this and return. So this is the brute force approach, and this will go to the exponential. So I will recommend that you should try this solution also by dry run. Then you will able to see that how it is happening. Otherwise, you will not get the idea that how the code is internally working. So for the optimized solution, it is very quiet and simple one. Just what I did here, I have taken the answer as a long because the statement itself is given as a long. Here, if you will see, the answer will reach to, means we have to take the modulo 10 raised to power 9 plus 7. So for taking modulo, I've taken the answer as a long, and from this part mod, and I have sorted this one, and I've taken the power as 1 because every time we need to multiply 2 raised to power I. So for each iteration, I will just update the power by multiplying 2. So here I have traversed all the elements. I have updated the power at each situation. I'm just doing mod because the question itself has mentioned that you need to take the mod 10 to the power 9 plus 7 because answer is going to be very large. So after that, just I'm updating the current answer with the difference between ith element and the from the last also ith element, and I'm just multiplying the power. I'm taking the mod, and here I'm returning just the updated answer that we have calculated from this loop. And why I have taken the internal typecasting, because the answer plus mod will again overflow, so you need to cast into the integer and then take mod, and finally you have to take the mod. So just you need to return the calculated answer here, right? So these are two approaches, and you can submit the solution on the portal also, and you will see it will be accepted. So just submit this one. I think everything is correct. Variable and nums, everything is correct. Just try by running this one. Yeah, it is correct, and now submit this one. Yeah, it is getting accepted. So just try with yourself this one, and we'll meet in the next session and will the amazing problem. So this is the quite difficult one, not difficult one, a bit of mathematics, but it's interesting one. So you will be, I hope you will be easily able to solve this problem from this video. So thanks for watching. We'll meet in the next session.